Section 4.3 homework, 0.25-T. The time it takes for a planet to complete its orbit around a particular star is called the planet's sidereal year. The sidereal year of a planet is related to the distance the planet is from the star. The accompanying data shows the distance of the planets from a particular star and their sidereal years. We're going to complete parts A through E. The first part is we want to be able to draw a scatter diagram of the data treating distance from the star as the explanatory variable. So I'm going to go ahead and open this up. Okay, so again, the distance from the star is the explanatory variable, meaning x, and the sidereal year y is going to represent the response variable. So I'm going to open this data up into StatCrunch. Okay, so here's our data. And so what we want to do is we want to choose this column and the third column here and create a scatter plot. So let's go ahead and do that. So we're going to select the x variable to be the distance from the star. The y variable is going to be the sidereal year. Okay, then we're going to scroll down a little further. We're going to make sure that we have our points. Okay, and then we're going to go ahead, select horizontal and vertical lines, and now let's go ahead and select compute. So here is our scatter diagram. So let's compare it to the other ones here. So if we take a look at A, here's our scatter diagram for part A. Here's the one from StatCrunch. So we can see here that we have a few points down here. And this is 1,000, this is 2,000. So we have these points located here. There's our 2 points there. There's another point. There's another point there, and then that point there. And now recall that we want to make sure that the x-axis is the explanatory variable, which represents the distance, and then this is the sidereal year. So it's possible that it could be choice A. Okay, now if we take a look at choice B, the sidereal year is already in the horizontal axis, so we can not include B. Let's take a look at C. If we look at C and look at those points compared to our scatter plot here, this does not represent that scatter plot, so we're going to eliminate C. Now let's take a look at D. If we take a look at D, you'll also see that those points don't match. So therefore, our answer is going to be A. And therefore, there's our scatter plot for A. Now it says, determine the correlation between distance and the sidereal year. So I'm going to come back up here. I'm going to close out the scatter plot. And what I want to do is I'm going to go to Stat. We're going to go to Summary Stats. And then we want to be able to find the correlation between those two. So we're going to select the distance from the star and the sidereal year. And then we're going to select Compute. And there is our correlation. It says to round it to 3 decimal places. So round this to 3 decimal places. That 5 means we need to round that up to 0.989. So therefore, 0.989 is going to be the correlation between those. Okay, now it says, does this imply a linear relation between distance and sidereal year? Well, yeah. Well, first of all, if we take a look at the value of 0.9, it's close to 1. And if we come back and take a look at the scatter plot, right, we also know that this represents a possible linear situation. So therefore, we're going to say yes. Okay, now it says compute the least squares regression line. So we want to be able to find the least squares regression line. So in order to do that, we're going to go to Stat, and we're going to select Regression, and then go to Simple Linear. Again, make sure our x variable represents the distance from the star. The y variable represents the sidereal year. Okay, and then we're going to scroll all the way down. Okay, and then we're going to go ahead and then just select Compute. So now if we take a look here, we know that the slope, and it says round to 3 decimal places, the slope is the value that you multiply by x, and we're going to multiply that, we're going to round it to 3 decimal places. So round it to 3 decimal places gives us 0.065. So that is the slope, 0.065. And then we want to be able to then use the y-intercept. And so the y-intercept here is that value, and it tells us to round the intercept to 1 decimal place as needed. So we need to round that to 1 decimal place. That 9 is going to make that 4 change to 5. So we're going to put in negative 12.5, and that should give us our least squares regression line. Okay, now it says to plot the residuals against the distance from the star and then choose the correct graph below. So now we're going to go back to our stat crunch. We're going to select our options and then select edit, because what we want to do is we want to create a residual plot. So now everything is pretty much selected other than the display or the graphs. So you see where it says graphs, we're going to scroll down to make sure that we're going to graph the residuals versus the x values. So the x values is going to represent the distance, and the y-axis is going to be the residuals. So let's go ahead and select compute, and then what we're going to do is we're going to just maximize this screen a little bit, go to the right, and now we're going to see the residuals. Now, if you notice here, we need to also include the grid lines, so we're going to come back here and then scroll down and make sure that the horizontal lines and the vertical lines are selected. Let's take a look at this graph. Now we can see this a little bit better. So this is the residuals. So if we take a look at A, we can see that those points are all on this line, so it's not going to match this one. Now if we look at B, it kind of looks similar. Okay, if we look at C, it doesn't have the same shape, and D doesn't have the same shape. So it looks like our answer is going to be B for the residual plot. Okay, now it says, do you think the least squares regression line is a good model, and why? So let's go over some information here. Okay, to determine if a linear model is appropriate, a residual plot is used. Now, if a plot of the residuals against the explanatory variable shows a discernible pattern, such as a curve, then the explanatory and the response variable may not be linear related. If a plot of the residuals against the explanatory variable shows the spread of the residuals increasing or decreasing as the explanatory variable increases, then a strict requirement of the linear model is violated. Now, recall that outliers are extreme observations, so an outlier can also be thought of as an observation that does not fit the overall pattern of the data. Well, the residuals follow a U-shaped pattern. Let's take a look at that. Okay, when we select B, it's showing a U-shaped pattern. Okay, the spread of the residuals does not increase or decrease consistently as the explanatory variable increases. So that's the case here. Okay, and it says there are no outliers in the residual plot because no residuals lie far from the rest of the plot. And so we're going to use this information then to determine that. So do you think the least squares regression line is a good model, and why? So are we going to say yes because the residuals form a pattern? No, because the residuals form a pattern. No, because the residuals do not form a pattern. Yes, because the scatter plot appears to be a straight line. And yes, because the residuals do not form a pattern. And so therefore, the answer is going to be B. No, because the residuals form this U-shaped pattern.